very final. It's not going to be the same. And then today we're going to talk about DNS, DHCP, networking stuff. So before I start with any operating system, I'm going to discuss DNS and DHCP. DNS stands for Domain Name Services, and DHCP stands for Dynamic Host Configuration Protocol. And DNS is the heart of the internet. Every person, every server, every computer, every client, whether it's a portal, iPhone, a cell phone, a laptop, a desktop, a server, anything that is connected on the network, if they want to do communication between multiple machines, they are going to be using DNS. And DNS stands for Domain Name Services. And Domain Name Services is basically supported by having some hardware, and on top of the hardware, there's software running. The hardware or Cisco hardware like routers, switches, hubs, and you can name a lot of them, whether it's Cisco or some other companies. There are a lot of other companies that are working on it, and then I'm just talking about Cisco in general because this is about 60 or 70% of the network that nowadays are used or Cisco. And there's Akamai, there's a lot of other ones, but let's just concentrate on what is DNS first. DNS is supported by a software called Bind. Bind is the Berkeley Industry named domain software, Internet Consortium. Let me see if I could go bind.org. Is it the it is something else, bind. Yeah, ISC, the website is called isc.org, Internet Service, Internet System Consortium. And then they provide the bind itself. Bind stands for Berkeley Industry Name Domains. And then this one is actually something that you have to download. The version that is current one is Bind 9. So I have built 9 on multiple Linux platforms and DNS name servers. And what you do is you download the Bind version and you install it on a Linux machine. And once you have it installed, then you have the option of just running as a name server. Name servers are responding to queries, name server 1, name server 2. So for example, each one of these ones, when we go to a UNIX machine, let me open this one. I'm going to jump back and forth between the Unix machine and the Windows machine and show you different files and different configuration. etc resolve.conf file. There's no E after resolve here. So this is the name server is one of the directories inside the resolve.conf file. And that one is basically telling you what is the name server that is responding to my queries. So every time that I'm on the network, I have an IP address. That IP address is tied to this host name. So if I just say cat etc host, then you could see this by default, this machine, fconfig -a, and then look at the top here. This is the interface, and then this is the IP address. So a machine has to have an IP address. In this case, since I'm on a IP version 4, and I'm using IP version 4, and then you can see here there's IP version 6 MAC address, but my connections are using IP version 4, and net mask this, and then IP address this. So with this IP address being up and running, because of this field right here, it says that this one is up and running, I need to just be able to ping my gateway. So if I do a netstat -an, and then, sorry, a netstat -rn, routing table and numbers, if I look at that one, and there's a gateway here. The gateway that is showing here by default is gateway 10.0.2.2 is up and running, and then this is also one of the netmask gateway that is showing that is up. So when I do a ping on 192.168.122.0, that is 192.168.0. Do you want to ping a broadcast -b? Check -b. So I'm not actually broadcasting it on it. So I'm going to do the gateway. Normally the IP address is .1. And then in this case, my gateway was showing that I'm doing 254 IP address. So this is my actual gateway that is coming from the internet service provider in my house, which is 168.254.254, and that's Frontier. So it is connecting to the Frontier gateway, and Frontier gateway, if I do a NIST lookup for that IP address 192.168.254.254, that translates to gateway.home, which is my home. But then if you do a NIST lookup, let's say frontier.com, it shows that Frontier is listening to this IP address. This is the IP address that is doing it. At any company that you're looking up for it, they have an IP address as well as other records and DNS, and then those records are being resolved because what is on a couple of configuration file. Another configuration file that's very important here is called nsswitch.com file. So if I just do a grep -i for host on the etc nsswitch.com file, nsswitch.com file is a file called name server switch. And so if I'm looking for any host on the system like google.com or frontier.com or xyz.com, I need to just look for this host to say this host field, how it should find it. So this is the host file. It has these parameters and these values. So the host directive, it says, look inside your etc directory for files first. If there's any file for the host, like for example, etc host, it has the information about the IP address. If I just do etc host as cat, and that is concatenating the contents of the etc host file. So if I just do that, it is basically gonna say okay, I found out a website called mysolaris.ourunix.com to the IP address of this. And then that's there. And then another one is called ourunix.com with the IP address of 24. And then based on this, since I'm on the same gateway, that tells me that, okay, on my .24 IP address, I'm running a host name called ourunix.com. So if I do a ping on 192.168.254.4, it's going to just try to connect to my MAC address, which is says host name unreachable, because it's trying to go through name resolution. And let me show you how it does that. So on this one, I tricked the DNS to say that, okay, I'm having a static IP address, but it's actually a redirection because my web hosting company and that is providing my service for DNS, that one is just another company called namecheap.com. So I went there registered, and then I come up with an IP address that is basically using my DHCP to get a actually static IP address on the internet. That way, when somebody is trying to use that machine, then I could connect to it. So like here, if I just say SSH minus LW Wahid Lutfi, and then 192.168.254.24. I could also use the website to connect and everything else. So right here, it is prompting me for password. And then you can see that this is a virtual box. I mean, actually, this is a Mac machine that I'm running on my home that is connected on the internet through DHCP that is serving that is using a static IP address of the web hosting company provider. So I could still, I don't have to have a static IP to connect, but this is what I did to configure it that way. So right here, I am running Mac OS X, as you can see, Darwin BSD version. And if I do fconfig -a on this one, you can see on the same subnet 192.168, I have these aliases that are up and running. So one of them is .24 that I just logged in, and there. And then the file, again here, etc resolve.com file, it has the name server information. For this machine, and the name server is also 254, but in addition, I have these other name servers. So the name server job is that to look for all the queries that I'm doing to find out the IP address and the host name information as a result, and then that way I could do it. If I say nslookup google.com, this one is going to give me the Google IP address, but how is that going to resolve it? It is going to be this. This one is going to look at it. First of all, it just says, okay, grep -i. Let me just say on this one, let's see, nsswitch.com file. Okay, this is Mac, nsswitch.com file. Most likely it's in a different location. I could just say arp -a. Let's see whether the ARP cache is showing for the machines that I could connect to. So in addition to .45, I could connect to some of these ones, like .25 is my Solaris machine. So if I just say cat etc host, you can see that right here, .25 is configured to go to this other machine, Solaris machine. So if I just try to see if that one is running, 192.168.254.25, if that one is, yeah, it is pingable. So I could SSH either by the IP address, or I could do it by this host name or this host name, since it is there. The reason that I showed you earlier that it says nsoh.conf file host is there, if it finds it on this file, then it is not going to just worry about another file. So like on my Linux machine, host name, the etc nsoh.conf file is there. If I say grep-i host etc nsoh.conf file, nsoh.conf file, so sorry, nsoh.conf file. If you look at this one, it says look at the files first. Since there's a etc host file and that entry is there, like for example, my Solaris is there, it's going to find it, but Google is not there. So if Google is not there and I don't see on my etc host file here, or Google or Oracle or other companies, IBM.com, Amazon.com, none of them are there. So how is that going to resolve? It says, okay, look at the etc host file first. It looks for that one, it did not find Google. Then it's going to say, okay, I did not find, now it's going to look at DNS. The DNS is going to say, okay, I found it on DNS, but in order to look on DNS, it has to look at this etc resolve.conf file. And then it says, okay, I found it on this gateway. Now, if I just do this gateway, when I do ns lookup on google.com, that this gateway is going to find it to just get that information. How do you know that this gateway is actually resolving it from the resolve.conf file? Is if you do a traceroute command or do a ping command, for example, ping, you could see pinging to that IP address, and it tells you that the IP address of that one is coming here. But at the same time, if I do a trace route on it, this is UNIX, so trace route command, you could see that it resolved it right away. And it went from my gateway to trace route Google to 10.0.0.2, and then from there it resolved it. If you recall it, netstat -rn earlier, I was getting the 10.0.2 as gateway, and I was saying that it's up and running. So it does resolve it based on that one. If I do, for example, a query on Google with, say, show me the query with a name, a record. So this is all, sorry, a for lowercase, a record, Google. Oh, not ping. I'm just not putting in this lookup. Otherwise, that case sensitivity is not a problem. I could do it a uppercase. That's still a record. And then if I want to say, show me the C record, it's a canonical name or C name, and that's there. If I say, show me the MX record, mail exchanger record, you will see the mail exchanger. So within this lookup, certain properties, certain options and parameters that you pass in, you get certain information. MX record is for mail exchanger. Every time you use SMTP to send mail or any email stuff, and it goes through the MX record on the DNS. This is part of the DNS record as a total, but the main record is a record, which is based on the IP address of the machine. So by default, if you don't provide any parameter, it produces the A record of Google. So the same thing is what other company, like let's say IBM.com. And then same thing with Amazon, Oracle. You could get so a lot of the companies like Intel, and then maybe Cisco, CSC, CO. Yeah. So a lot of the company, when you do check on them, they allow ping, but maybe some companies or some universities like Pasadena, www.pasadena, Pasadena.edu. If you type in Pasadena.edu, you get an IP address, but if you're trying to ping it, it may just time out because what it is it's not allowing people to just hit their gateway just by pinging and just do some sort of DOS attack. DOS stands for denial of service attack, and there's a DDoS attack, which stands for a distributed denial of service attack. Sometimes people write code on some servers, could be distributed servers. That's why it's called distributed denial of service attack. And they are sending requests to a certain web hosting companies or certain companies, certain universities, certain things, in order to just overwhelm the server with their request. And then as a result, if they loop up it a million times to go to Google, then it's going to just fill up their request on that server to just send the information to Google, and then the valid requests are just going to be slowed down. But that's not something that you can stop Google for any performance issue. Google is much smarter than that, so they built a lot of companies. They do that. They do have firewall, like for example on the Pasadena.edu, most likely our firewall blocks for for Echo, and each one of these services actually they have a port information, everything that is connected. So Google, for example, they could have cluster of servers, and those cluster of servers, they check for these kind of requests to say if a spam or any other requests that are coming as a result of duplicate request for some certain amount, they do not allow that one. They discard it before even the request comes in. So those requests are already discarded. You cannot just say, oh, I'm going to have a distributed servers and I'm going to send and wget or curl or ping request to certain sites of Yahoo, Google, or anything. They had resolved those ones maybe 20 years ago or 10 years ago. At least on Yahoo, there were times that long time ago, people just had done that one, and then they found out how to stop those kind of DDoS attack and DOS attack. And Google is also has done that one a number of times, and a lot of companies, they have to protect themselves, and that's a smart way to just discard and unwanted request that is not part of valid request. So here, if I just show you what is like, for example, ping, grep -i ping etc services. There's a file called etc services that has port information for ping. If I do it with w -iw, this is just showing me what are the port that when we do a ping that is being used. And if I do, for example, SNMP, what are the ports that are being used? If I do SSH, port 22, for example, is used, and then so right here is port 22 for both TCP and UDP is used. Let me just do minus W only. And then you could do a lot of them that are on these services. Whether if I do a egrep, I can put multiple string SSH. Let's say telnet, um, finger, LDAP, and then what else? We could check for port 22, port 80. 80 is HTTP, and then HTTPS is also 443. So if you look at this one, you can see the numbers that are just all these ports. So that's the server, every time you start with a service, like for example, 22, I was saying that 22, if I just say system CTL status for SSHD, this one will say that SSHD is up and running, is active. And then if I say, okay, show me the LSOF list of open files for this port, for this IP address, I could just say LSOF minus P 1326. This is basically showing that this is a port that is open, but because I'm not root, I have no permission to see the other ones. It says permission denied. So if I just do a sudo in front of this with sudo access and then type in my sudo privilege, then it's gonna just run the SSH information, and it's gonna give me more list of open files, all the shared objects, everything that are connected to it. But what I'm interested here is that find out the name of the socket that is connected to, and then what port and that I'm running here, right? So here, this is 1326 is the process ID. If I look at grep minus I 1326, I could get further information about that process and then say, go ahead, do a netstat minus an for all of them, and then grep for minus I listen. The reason I say minus I is that I'm ignoring the string case sensitivity. And then normally these ones that are running, it's all in uppercase. So I could say grep less than in uppercase. It would do the same thing as grep minus I, and then I don't have to type everything in uppercase. So grep minus I, ignore the case, listen, and then at this time, if I'm like just doing this one with 5 more, you could see that there's a lot of ports that are active, and 22 is one of them. So I could do that, or I say, show me the port 22 only. And then this 122, you can see that it is listening to all the ports in that subnet of 0.0. If you recall, if when I say netstat minus rn, this one was showing the destination is 0.0.0. This is where it is coming. So on this IP address on this machine, SSHD is running on port 22. And then based on that one, now I can SSH to this machine, and then SSH out also as a client, but SSH in is the server D. And there's configuration file for this one under etc directory. So if I go to SSH directory, and then right there, and there's a number of files. One of the files is SSH underscore config, which is for client, and then SSHD for daemon for the server side. This one has a lot of other fields and directive that you could just say, show me the configuration by looking at it. And that one will also tells you that you need a sudo privilege to do it. Sudo And then you can see, because I provide the pseudo privilege already, it says that. So if I want to just go to another machine and I want to just make sure I come into this machine, I want to make sure that I can get a graphic information, then I have to do the X forwarding to a value to yes. And that would allow me and do this. There's a lot of other parameters here you could change. For example, somebody can get into the console as root or not. That's whether it's yes or no. Like password authentication is there, challenge password, and root information. So if I just look for in this file as a grep for root on this file, you can see that there's a permit root login, yes. By default, that one is no. You don't want to just allow it. That's why it's commented out. But if you decide to do it temporary for some reason that it's unknown to me at this time, but you might have a reason to say, I need to get the console as root, and then you just temporarily set it. But that's a security issue. You don't want to do that. So that nswitch.conf file was resolving through those information, and then at the same time we did look at the fconfig. So fconfig -a, it gives me this IP address for this interface. So ENP0S3. I could do the same thing here, and instead of -a, I could say ENP0S3, like that, and then that would ENP, not G, ENPS. Let me just do this one again. fconfig ENP0S3. So you could see that interface itself, and similar for like the other one, loopback interface, LO. So if I just do that one and give the loopback interface information, I only get that parameters. And again, for this information, when you do it, if you're interested to not only get the IP address, you could just do other commands similar to, say, for example, grep -i inet. So I could get only the inet portion of it. And then if I'm just interested to get only IP address of this one from this, I could say head -1. I could make it unique by doing another grep on net mask, and that would do it there. But now I know it's there. I could only pick up that, or just say grep -i net mask. That will also give me the same thing. But then if I'm just interested on the second field of it, only the IP address, I could just say auth and then print $2 of that one, and then now I have the IP address. So if I just want to send that information to, let's say, for example, let's say we call it IP. IP is equal, you could, IP is equal, and then when you do the backtick, basically it is just using this as the input to that field, and then now I just store it to that variable called IP. So I could just say ping $IP would be the same thing as if I just did it that way. And now you could just do trace route that IP. You could basically this trace routing to itself. It is similar to, say, trace route localhost, and or trace route 127.0.0.1. because this one is already on the etc host file. So DNS is just resolving it based on how you make the request and where that information is written. It looks at the files first, it finds it here, it doesn't look at the DNS. And if it doesn't find it on both, so for example, let's see NS switch. NS switch is named server switch. It's very important file. Sorry, and grep -i host etc ns switch. There's two S's there. So that one, you can see the etc hosts has that information saying that either look inside the local files, and if it finds it on the etc host information, then just don't look at anywhere else. If it doesn't find it on etc host, then it's going to look at DNS. And if it doesn't find it on DNS, most likely a host is going to be found on DNS. You could have my host name here, something that would go to your bind or DNS version, and that is local. For some reason you just decided to do it differently, you could look up there. But you could also look for like on an LDAP server too for getting the host name entry from there. But normally on the host entry, you look for files and DNS. What if you're looking for a user? For example, I type in wlutfi here, my ID is wlutfi. How does that find it? There's a UNIX command on DNS that is called finger. And when you do finger a username at certain host, it will resolve on that domain. But if I just also want to know whether this user is actually exists on my machine or on DNS or somewhere else on LDAP server or Kerberos server, somewhere Active Directory server, how this user is getting authenticated on the system. Again, you have to look at this file, grep -i. This time, instead of saying host, you're going to say password. Password on the etcnswitch.com file. There's a field on the nsswitch.com file, and that has the entry for password. It says look for the files and then look for the system security services, and then if you find it in there, that's great. But in the files, in this case, it's not looking for host. It's going to look for a file called password and a file called shadow. etc password is local and etc shadow is local, and then there's a file called etc group. So those three files are on the system. Notice that shadow is permissions or all blocked. Only root could see the content of it. But on the etc password file, there's most likely an entry for wlutfi, because on this system, I'm only looking files and then SSS. And then since SSS is running, grep -i SSSD, actually, on this case, the system security services are enabled due to the SSH. So if I say man SSS, it will just say this is based on the SSSD. Yeah, system security service daemon. This is basically, I'm not running it on this system, but it is just allowing me to connect to through the password file and shadow files and group files. So if I say grep -i wlutfi etc password, is going to find a password file with user ID 1000, group ID 1000. I could also look for this one, say get int password wlutfi, that would also, sorry, get end, not env. And get end, that would also give me the same information. So the entries that are there in the ATC's nsswitch.com file helps us find out a lot of values. Like if you're using an IS plus or an IS, that's a network information system that was put together by Sun Microsystem long time ago, and that is mostly deprecated. And the newer version people are using is LDAP, Lightweight Direct Access Protocol. But the reason that it is there because NIS was sending information in clear text, and LDAP doesn't. LDAP is more secure in that way. And then you can see that these information like password, shadow, group, all of them are using same kind of files. First, look at the local files on ATC directory, then look on the system security services. And if you don't find it, and then you don't have it at this case. But on other servers, we may have LDAP, depending on whether you have an LDAP server or not, or Kerberos, or maybe Active Directory. And then you can see a lot of other files, or like Ethernet and NetMask, so networks. And if I look at the ETC networks, ETC networks contents, you basically have the default network, which is that, the loopback interface, and then the link local, and how those are being linked together. And then a route command is also there. So route, it's basically, you could add a route to the gateway and to add additional gateways. So you say route, add default gateway, and then provide IP address and gateway information. You could add additional gateways if you want. Sometimes you create additional gateways in order to just have a static routing tables. Sometimes these are all dynamic. So if you do arc -a, shows all the arc cache that whatever is there. So in here, I logged into this machine, which is my UNIX. I could also do SSH -l my Solaris. And then when I do -l, I have to give a username. In this case is this as the username. Or I could say SSH wlutfi at my Solaris. That would prompt me the same thing. So now I'm on a Solaris machine in a Solaris 11. Solaris is a Unix machine. It's not a Linux machine. There's a difference between Unix and Linux. Unix was written originally, and Berkeley, not at Berkeley, sorry, originally was written at the AT&T Bell Laboratory by Ken Thompson and Dennis Ritchie. Dennis Ritchie wrote the entire Unix with C programming language, and then Dennis wrote a lot of programs on Unix Ken wrote a lot of programs similar to grep and SED and other ones on the Unix as well, and they both were the first pioneer of the AT&T version of Unix back in 1969 and 70, and then later on, Bell Laboratory became Lucent, and Lucent became Alcatel Lucent technology. But Unix was also the first version of Unix that was written by University of Berkeley, called BSD, Berkeley Software Distribution, is the current version of Solaris. and current version of Linux, Linux, I'm sorry, not current version of Linux, current version of Mac OS X. Mac OS X is also based on BSD called Darwin, but the BSD is the original core part of the OS for both Sun Solaris and Mac OS X. Sun Solaris started with version 5, and if I just show you this file, etc release, they are basically having Solaris 11 with 5.11. It shows there because it started with 5, and then everything, if you have release 11, you would have a 5.11. If you have 10, you have 5.10 SunOS. The SunOS is the version, and this is also called Solaris Express or x86 version of Solaris, and that is running. And then if I just do -S for system, and then -R for revision, and then -M for machine type, and so on. A lot of these parameters are passed on. You could do a uname-h for uname --help, and then it will give you all the parameters, whatever version information that you're looking for is there. There's also ISA info on Solaris that will just tell you what processor and everything that you're running. PSR info -A, not sorry, not -A. PSR info -P would give you the number of processor that you have. -V would give you the verbose information in terms of the details of and the speed and everything else on the processor. You could check on it. On the Solaris, you could still do a nice lookup. Let's say google.com, trace route, route, let's say IBM.com. You could check it. And notice on the IBM, I had to go from my gateway through multiple connection until it resolves it. The number of hops that jumps in between these connections, it is a lot in this case. So, and that's why whenever connection is not coming in seconds, unless nanoseconds, it is going to show you, like for example, this one is 43 milliseconds, but the previous one, it took about 6 or 8 seconds. That is a lot, 8 point some millisecond, 8.3 millisecond. So sometimes this connection, it is not supposed to be there. So I'm gonna just stop this one. I don't need to do anything on that. I could just say, for example, do a trace route on Google and see if Google is gonna resolve faster. It does go through a number of them. The reason it goes a number of hops is because I'm inside a virtual box that is connected inside a Mac, and then that's connected to a gateway, and then that's gateway is Frontier, and that network is only a wireless network, and it is slower. So a lot of that one adds up when you're just looking at the end-to-end time frame of how fast this should be resolving, but it did resolve it. And then here I have a look at the resolve.com file. You have that one. etc sometimes default gateway. So let's say let's etc default router is the file that I'm looking for. If default, so I need to do because there's a etc default directory, and that one has all the information. On Solaris, there's also etc inet directory, and then inet is all the networking configurations there, whether it's NTP, netmask, host file. So if I look at the etc host, that is symbolic link to inet etc host. Same thing with the netmasks, and that is also a symbolic net. So if I'm on this directory, I could say cat etc host, or I could say cat etc host since I'm there, or cat netmasks. And then so here, all this information is going to allow me to just be on the network. Since I'm on the network, I could do a config -a, and then I get my IP address of this network. And this one, it says I'm using the interface called E1000G0, and that's the IP address of it. So if I just do a fconfig E1000G0, it will just respond to that as well. And so what else we could say? Oh, services. And here, if I just go SVCS -a, all the services that are running on Solaris, it's going to show me all of them here that are running, and if they are disabled. So if I look for grep -i online, this is the list of the the services that are online. Word count -l is huge. 103 services is running on this machine. DNS is one of them. Network is another one. SendMail is another one. CentOS is another one. All these ones are protocol that you could use. In addition to this, nslookup, another one. On Solaris, you have commands like snoop. You have commands that you could do snoop, and you can do a spray, and then you can do strace. A lot of these commands you could check on the validity of processes. On Linux, you have tcp dump and other commands that will support a similar configuration. Nmap is another command that you could use to do some sort of checking on the ports availability of what ports are running on what host, and based on that one, you could just check on them to say, well, I need to connect to port 80. Is the port 80 up and running on this host? If you do netstat -an or LSOF, locally you can find that one, but if you want it on a server side, you could do nmap commands, or on the server side, meaning that if you're doing it on remote server, not just local server. So here, like for example, you do these ones. If I just do check for services with network only, you could see that this is a network is online, and then I could just stop the network and start the network and everything by doing HVC-DM and disable, and then network, or enable network, refresh and everything. All these options are under HVC-ADM commands. HVC-ADM supports you, and that is a services administrator, to do enable, disable, restart, refresh, mark, clear, milestone, everything with it. Similar to Solaris HVC-ADM command, on Linux you have systemctl, and then that one is basically allowing you to control your services, status for everything. So if I just say systemctl status and network, there's a service called network, and it's active. And this is the directory where the network starts, the configuration. If I say network start, It will do it as a legacy old system, or it could also do systemctl, a stop network and a start network. A stop would stop it, and a start would start it, and then other parameter like restart would restart, and so on. If I want to look at the configuration of this file, I could do more etc rc.d and net.d network. Here you could see all the configuration files of how I started, or I could say systemctl cat network.services. So this would .service. .service would be like the service. So if you don't put .service, by default it is assumed. You could get that information for the network service. And then you could see the option for a start is exact start, and it's for a stop it there. If I just do this one, is the same thing. And then if I just want to do a show content of it to see all the variables, whether initialized parameters for it, I could do the same thing. And this is just true for all the other services. For example, if I'm looking for SNMP, then I could get the parameter for sample network messaging protocol. If I want to do it for LDAP, I could do that. If I would just want to get for SSH, for example, secure shell, all of these ones are there. And then if I just want to cat that one to see the actual files, you could see cat SSHD. It's not SSH, it's SSHD, secure shell daemon. That's the daemon that is running on the server side. That's a service. SSH is just a client version. So we did discuss those. It's 9:28. Let's see if there's anything on the topic before I go more on Unix and Linux side. But I need to cover, and I'm going to cover Windows as well. So IP command. IP command here, if you look at the IP on the IP command, so like if I'm on Solaris machine here, I type in svcs -a, it will just give me the output. But if I just say, let's say I say IP, it's not going to do that. If I say systemctl, that's not going to be there. Those are a Linux command. So similar to that one, if I'm just coming here and I say IP, it's going to provide me the information. So IPA, you will get a record of it. So if I just say SVCS, because that's not a Solaris command, it says command not found. Or SVC ADM, the Solaris command is not. So in the platform like ZFS, if it doesn't have ZFS here, ZFS list, these commands will not work on Linux. Just because you're on Linux does not mean that you have same utilities that are working on a Unix platform, and vice versa. And since you're on the Unix, if you just run here ZFS list, it will just show that zettabyte file system on this system. So if I'm just doing it on Linux, then I need to do df-h or cat etc fstab file. And notice that this one is called fstab file system table. It has similar parameter, but it is showing xfs extended file system as the main file system. By default, on a Windows virtual box, you get the xfs for Linux CentOS, But if you're running Linux CentOS or Red Hat on a
I need the host, and I gotta hop back into my class now. Okay.
if you're going back to an Intel, then obviously you're going to get not Intel, sorry. If you're getting
I made you the host, and I gotta hop back into my class now. Right.
okay, let me just put Cal on mute. Unfortunately, he's talking while I'm talking.
Oh, sorry about that.
That's okay. I'll just put you on mute. Is it okay? Okay, or should I put you on mute? Or you're good?
I just muted myself.
Thank you. Thank you. So basically, if you're on a different platform versus Intel versus maybe Spark or something else, then you are running Red Hat or CentOS. And that sense, if you're just doing um, some of these commands, the XFS, for example, will be just showing the extended 4 file system rather than XFS here. If you're using XFS, yes, it will show XFS. If you're using extended 3 file system or extended 2 or extended 4, and by default, Red Hat and Linux, they come up with either extended 4 file system or XFS when you install them. So on the Solaris platform, like I was showing you, here, if you look at the etc fstab, on Solaris, they call this one virtual fstab, virtual file system table. So it is etc vfstab file. And the content of etc virtual file system table, it is this. And then you can see the file system type that is supported is proc, devfs, and everything else, but they're all based on the ZFS here. The proc file system is a memory-based file system. Swap file is, as you can see, is a swap file system. DevFS is a device file system, and all those other object system that are be created here, it's recognized similar to what's recognized here. So if I look at here, say swap minus L, it is not showing me this swap on minus S, and then you could get the swap on, and then the swap partition that is enabled on the system. If I do a free, you can see the contents of how much memory I'm running and what swap I have. Free minus S minus H would give me a human readable 2 GB of swap space on this. And there are files on the proc file system that tells you information about the system also. So on the slash proc file system, which is memory based, there's a lot of files. One of them is Mem Info. Mem Info. It's if I just cut that one, say proc mem info, it will just basically tell me how much memory I have, 1.8 gig of total memory. Similar, if I just do CPU info, these are all coming from the memory pseudo file system information. And then if I just need the similar information on a system, I could do a prt conf-v and grep minus I memory. So that would give me the memory, how much is 1 gig allocated for that one. Because I have a total of 4 gig on that Mac. If I'm running a Solaris, 1 gig is plenty of space for it to run, and it's fast enough in some sense. But your resources sometimes limit your performance also. It's not the OS only. I'm gonna go come back here. So we did cover all these commands: ping, traceroute, hostname CTL on Linux CentOS. So on Solaris, right here, host name is a command, but host name CTL is not. So here on um, system 7, system D with Linux 7 and Red Hat 7's hostname CTL is also a command that it provides you information related to your system. And then this one, it says that it's a kernel virtual machine virtualization based VM. And the computer name, the local host name, and everything else is there. So we did cover SVC, ADM, and SVC. All of this we covered it, everything, except the IP config on Windows, which I'm going to jump in now. And now we discussed everything on Unix and Linux, and then we're going to discuss Windows. So on Windows, you have similar commands. And instead of ipconfig, instead of fconfig, you have ipconfig. Ipconfig basically give you IP configuration of the system. And if you go ipconfig/all, you could do a pipe more. You get all the parameters for it, all the related parameters. And then if you just do ipconfig/renew, it will renew your DCP connection. There's other parameters that are there. So to get a list of parameter, if you do /h, it will give you help. And then the help, you can see with the ipconfig, you could try all these options. Renew or release your DCP connection for version 6, and then show class ID adapter. It's a lot of parameters that you could check for the ipconfig. And then they give also examples here that you could try each one of those ones. And then for ipconfig, when you know the host name, if I just say host name here, it will print the host name, similar to the other machines here that we used, that we used on each of these machines. You type in host name, it will just give you the same. So the command host name will just give you the machine name. Okay, so if I just go back on my Windows, when you look at the host name, let me just make this one bigger so you have one screen, clear screen. And then on Windows, on Unix, you have clear command. On Windows, you have clear screen command. So if I just say fconfig, this one, ipconfig, that's equivalent to fconfig there. And then if I say host name, it's just gonna give me the host name information. And then there's command on Windows that also does similar to Unix. So clear screen, if I say ns lookup google.com, it gave me the Google information, minus query is equal mx. It is all that information is going to work the same way that worked on the Unix machine. Also, I did not show you another way of doing ns lookup. If you just type in ns lookup without any argument, okay, without any argument, it is assuming that you're gonna just go to a prompt, and then from the prompt you could just type in ibm.com. It will give you the ibm.com. Now say google.com. So if you're doing multiple entry, oracle.com and www.w3schools.com, and you just get it, and then until you exit out. And then if you do, let's say, question mark here, it gives you the syntax of what you could set and what you could do. For example, the root is equal name if you want to set a default root, and then retry how many times you do, and then all those other options you could play around with it and get information. The same thing, it works on uh, Unix and Linux with this. And you can see, like right here, for example, the A record minus T for the type on this one, minus T for type, and you could say C name, A name, MX record, and name server, pointers, etc. So let's say we say minus T is, we gave C name, and then we say google.com, CNAME google.com, unrecognized. So it is not coming out here, but it is going to do it. Let's see. I could do a equal here, and then if I quit here, exit out of here, exit. Exit lowercase is understood, but not uppercase. So and let's look up minus T is, and then CNAME google.com, invalid T. So the type is equal. It looks like the type is minus Q is equal. CNAME might resolve it. Yeah, minus Q for query. The type, even though it says what type, it's not dash T, it's dash Q. So dash Q is a mixed record, and then says, show me for Google the C names. And then you could say name server one dot this as the primary server. And then, so whenever you hit the Google, it goes to the name server one as their primary server. And then the name server two, they might have a number of them. So if you look at this syntax here, it says NS. NS is going to give you the name of the server right here, or pointer for PTR for all the pointers there. And let's see what it is for the NS. Yeah, so you have a number of name server on Google, name server 1 through 4, and they're a round robin there. You could check it on it. For the A record, we already looked at it. What was other options there? NS lookup, question mark. The options are MX, we looked at it, CNAME, A record, pointers. We already looked at all of them. And so the trace route command, for example, trace route RT, rather than route, you do trace route, and then you say google.com. It will just go through the number of hops from this local PC to connect to Google. And once it resolves it, it's gonna resolve. Notice that it comes out 192.168.254, my gateway first. It hits my gateway first before it hits the Google gateway. And then the name server one is gonna be coming at some point for Google, and that's maybe this one, maybe later on. I just forgot what their IP address was. So if I just say this, and so let's do NS lookup on ns1.google.com, and then right there you could see that 216.239.32.10. 216. Okay, and then let's look at the number 2, 216, 239, and number 3, and number 4. And when we do trace route google.com, it hits my gateway, home gateway first, and then it gets hit the Frontier gateway, and then it's going through Frontier. It's still on the Frontier gateway, hasn't reached to Google yet. 74, 108, 170. And right here, it finds the IP address. So in this lookup, google.com, it is coming with 142 to resolve that. Okay, so the trace route is actually showing some other net, and from there, it eventually resolves it. But whether this is not the primary that we are heading it. So once we head the cluster or the edge server of Google, then Google is looking at it, say, okay, I'm going to resolve it to this host. One of 1,000 servers that are available in the Google network, they will resolve to one of them. And apparently it could be this one this time. If I do it another time, let's see if that one always resolved to the same IP address or it goes to another one on the same subnet. So always it starts with my gateway, then it hits the Frontier, same gate information. Then let's see, it goes on 172, same thing. But this time, instead of 20, it went to the host 18. And then this one is similar. It's a Frontier. And then 254.26 is same. This one is different. 237.14 host and 252. So now notice that these numbers are changing. That was accurate when I said it's going to hit the Google Edge server and then resolve it to one of the hosts. Last time it resolved it to this host. This time I resolve it to this host. And then the way it is done, it's all transparent to us, how it is going to be resolved. So if we do ns lookup LAX 170 S15 -n-f78.1e1100.net, that is showing this IP address, which is either 78. Last time we did the 78. I'm sorry. So fast. Yeah, 78 was last time, and that's what is showing there. This is 78. So, and let's look up how these files are being recognized. There's also a command like netview. Netview is just whatever is on your network, you could do it, and you can do a net use to map a drive and everything else. So netview / something, you could just say give me all of them, or netview of a particular host. You could just look up there. Since I'm not on a network, this one does not address. Behind all this configuration that I'm showing you on DNS, another one, what's important is to know is TCP IP. which is stand for Transmission Control Protocol, Internet Protocol, and then UDP as User Datagram Protocol. All the packets that are going through the internet through this Ethernet card or fiber optics cards or SCSI network, all of those ones, whether you're sending a small packet or a giant block of data, all of them has to transfer between the two machines through the IP, which is Internet Protocol. But it's either using a TCP connection or UDP connection. The difference between TCP connection and UDP, TCP is connection oriented, meaning that you're connecting to a machine, to a host, and you're having a connection. Based on each packet you send and receive, there's acknowledgement on the other end as happening, and then the next packet is going to be transferred. So those are protocol like SSH, Telnet, FTP, Secure FTP, SCOPY, RCOPY. All those ones are using the SSH secure connection or TCP/IP connection-oriented port. But UDP is like messages that are small and they're fast. They just like text messages, right? They're going through UDP, User Datagram Protocol. They are not connected to the system. So when you send a text message from your iPhone to another iPhone, you don't make a connection. You don't authenticate to the server or to another machine. You just basically write your text and it says send. And that send, it goes through the UDP protocol. Through the UDP protocol, so if I just show you on this, let's say, this is an important thing that I should have covered earlier when we were here. So I'm gonna just show you. So if I just say grep -I UDP on ETC services, there's ETC services, Okay, services, if I look at that one, you can see there's so many protocols that are just responding to UDP for everything. Everything that you do, whether it's SSH or secure shell, or LDAP or something, they allow both kind of protocol, TCP as well UDP. So TCP is Translation Control Protocol. And if I just look, for example, grep -I SSH for ETC services, you can see that it allows on port 22 TCP as well as UDP. And for every other ports that are connected, for example, let's say send mail. This is SNMP, basically send mail through port 25 SNMP, and that is connected, and the by default they're using port 25 for SNMP. Let's see. I'm going to check port 25 itself, and there's no need to do -I, and I'm going to do -W. And this one is SMTP. Did I do is an SNMP here? Yeah, a simple message time protocol. This is SMTP. SNMP is different, simple network message protocol. And that is a different protocol. And for SMTP is for sending mail through port 25. So the naming is a little bit similar, but for mail and send mail and everything else, we're using port 25, which is SMTP, Simple Mail Transfer Protocol. And then there's port 25, port 21. Let's say for port 21, port 21. That is FTP and port 23, I believe is 23 is for telnet. Yeah, and 22 is SSH. 21 is some of these ports. You don't have to memorize it. They're like HTTPS port 80, HTTPS port 44, 443. By default, you do those ones, but then you could just put it to other ports. And UNIX port 1 through 1024 or privilege ports that are already assigned by the system. Anything above that one, you can assign it and customize it based on your application. Let's come back here. Right here, we did discuss those one. Let's go to C directory. Let's go, I'm sorry, C directory. Going back here to Windows directory, system 32. And system 32, you have a lot of files here. You can see a lot of dynamic link libraries, a lot of executable for them. This is all your core part of the Windows operating system. So if I just look at this directory, as you can see, there's so much of these files. I'm gonna stop it. I don't need to look at all of them. The directory that I'm looking at here is called ATC. I'm sorry, drivers. And drivers first. So this drivers has a directory called ATC. And then all these drivers or system device drivers that are important files, and that's why they are extension of .sys. So if I just cd to ATC directory here, now I have a number of files that are important to the file. And so one of the important file is called etc hosts. Type host. Cat is not going to be equivalent to Unix. It's at that type. So also you can do more hosts. And then this one is basically telling you that what is the local host configured and what is and the information that you are going to get it. And this information is also similar here. Netstat -rn. It shows me all the routing information for and the network routing information for this host. So if I do pipe more here, you could see the top layer interface list and then IP routing table. And here is the gateway that I was telling you on the Unix side. This is the gateway here, the default, and then it is connected through that one. And the local host 127 this. So if I say ping local host, it is also going to go to the same file, but because it's using IP version 6, it is just going to configure that way. And so the local host, and then there was another file called services. Services, if you look at it, type services, if you look at it, it's similar to ATC services of that file. In this case, if I'm just saying find /i, and notice over there I was using grep command, here I'm using find command, because find is equivalent to grep on Linux or Unix, and find is the DOS version or Windows version of checking for a string inside another file. So in this case, I'm looking for a string called SSH. Then you will see that it's using port 22. If I'm looking for, let's say, SMTP, port 25, it is also used port 20. Notice that the same port, it does not change anything, like telnet telnet port 21, it is going to be 23, FTP 21, FTP, it is going to be showing that same port information on it. We SSH is doing that one. Let's say we do telnet to local host there. Telnet is not recognized, so that means that it's deprecated because it needs to be not installed on the system since it is clear text information. In order to install it, you just have to go and download it and install it. On Linux and other ones also, if something is not installed here already, you could do a yum search at telnet and then followed by yum install telnet. That would just install it for you. But then since it's deprecated, you don't want to just use that utility. You could just do yum uninstall telnet. But I'm not going to install it because I don't need to. I could use a secure version of SSH and connect it to the machine like I did earlier with this example here. I'm already using it here. And again here you could see on this machine SSHD was running. That's why I was able to connect to it right here. So if I just look at my process here, this is my process for this, and if I say P3, show me all the process 3 of my system. Solaris has a very nice way of proc file system that does a lot of commands with similar to Linux does it too in some ways, but some of it is more a Solaris configuration that later on other OSs just inheriting that information and say this is a nice feature to have it, and they do. So P3 will just show me all my process tree for the given system. I could do like a lot of other commands like pstack, pmap, so I could just look at the process. For example, this one is my process ID of this one. I could say P3 minus P21007. That will just show the process of that process. I don't need to do -P in this case because I'm providing a P3 command. I could just look at this one and then say, give me a process map of it. And then you could see the contents of all the shared objects that are loaded on the system with a process map of that process there. I could also say, give me a P stack on it, the content of the stack with the registers and everything. I could say P stop that process, P wait, or P anything, PWD, PWDX to show me the print working directory of executable where that process is started and that one. So since I'm in this directory, if I do this CD and then run the PWDX, notice it shows my print working directory of this command from home wlhp. And then if I go to etc directory, I run the same thing. It's all coming because of this proc file system 21007, and then current working directory. I could just look at these ones. There's a number of commands that you could do. One of them might be the PWDX, and then let's see, current working directory is the one there. So I could do say current working directory, and then if I just cat that file, it is a directory, and then yes, it is a directory. If I just look at the contents of it, it just It shows all the current working directories on that directory of the proc file system. So what else do we need to do? With proc file system, we discuss a number of them. etc. Let's see, which p map, and so user ben p star 5 more. It gives you a number of that proc file system related to command parc, p size, pkill, p. And there's a lot of them. So pkill, pgrep, process grep, and pkill to kill the process. PLDD for getting the files system type. So if I say which bash I have here, and I do LDD on user bin bash, this will show me all the shared objects that are tied to this process there. But then if I say echo $$, this is my process ID of my bash. And if I just say, okay, do a PLDD, a process link, dynamic link libraries, show me that one on the proc file system $$, because that's the number that is tied to it. So this will just show me all the process for that process bash, all the shared objects that are there. And notice that in addition to these that are already linked to it, in addition to these ones, then on the dynamic at runtime, you have also these two. That these two are just at runtime get a link to it. So there's a lot of nice stuff there. With Linux, Windows, you have these configuration files, and we looked at the type network. This is just the networks saying that the loopback interface 127. LM host.sam. This is security access manager or files that are SAM for and the database of the registry. Let me see what can I see the content of it. lmos.sam. Yeah, that might not be readable. It is actually. So what is sample rather than SAM, and that is not registry actually. It's sample lmhost host file. It's a sample file that you could just say how to create your host file, and that's already on the host files. Everything there similar. You can add on to the host by saying that IP address of our unix.com 192.168.254.25 or .24, and then put our unix.com or mysolaris.com, those information there, and then it could ping it. You could do an lookup our unix.com, since it's not on the etc host. It's going to look up on the gateway named server, and then resolves it from there. It finds it there. So if I say trace route our unix.com, you can trace root RT because of Windows. So you can see it is going through my gateway first to just find out our unix.com. The first hop, it finds out my gateway 192.168.254. Then it's going to say, okay, I'm going to connect to the rest of them and going through the frontier network, and then eventually it will go to a namecheap.com and then find out the IP address that is assigned to it, and comes out with the 47.154.104.127. And that's something that I just got from my machine by looking at the IP config command. Or you can go, if you don't know the IP config command or if config command on your Windows or Unix platform, you can go to a website called whatismyIPaddress.com, whatsmyip.com, and then it will just show the result of the output of IP config on your Windows or fconfig on your Unix. That IP address information is coming from a query string within your within their CGI script that it's parsing it, and whenever it comes out, eventually it will resolve it to a host by DNS. So I took that IP address and I configured it on the Namecheap web server page, and then as a result, I'm connected with TCP connection, solving all these network issues. Okay, at this time, I'm gonna pause the video or stop the video at this time, and then we will resume after like a 10-15 minutes break. So let's take a break and then we resume after there. I'm gonna also mute myself, and then you're welcome to take the 10-15 minutes break. So we will be back at about 10:25. It's 10:12 or 10:13 now.